Good afternoon, everyone. My name is Jerry Barron. I'm the Executive Director of the IR4 project, and I want to welcome you to the virtual coffee tour put on by IR4 for our friends and colleagues at Environmental Protection Agency. Before we get into the full tour, I just want to make a few opening comments. First of all, to acknowledge some of the work of some of the people behind the scenes in putting this on together. Van Starner, who has been with IR4 for many years, has been a key instrument in putting this tour together, as well as Jennifer Heiss, who you heard a few minutes ago give us the warning about when the conference was going to start. IR4 has been doing these tours for EPA for many years, more or less taking EPA up and down the Eastern Shore, Maryland, going over to Virginia, sometimes into Pennsylvania. Obviously, the pandemic has forced us to stop these in-person tours, and we've made the proverbial lemon into lemonade by doing virtual tours. This is the third in the series of virtual tours. The thought is, sometimes it'd be very hard to get 75, 100 or so EPA people out to Hawaii to learn about an exciting crop, or down to Puerto Rico to learn about the crop. So the thought was, let's take this opportunity for virtual tours and focus in on some of the crops that may not be easy to get to. So that was the purpose of this meeting or this tour today. So I'm going to, for the interest of time, I'm not going to say too much more. I'll have a few more times to comment or two, but let me turn it over to Ed Messina, who's Director of the Office of Pesticide Programs. Ed?
Hey, Jerry, this is Nancy. I don't see Ed in the participants just yet, so he might have gotten caught up in a previous meeting. I'll let you know when he's on.
Okay, we'll fit him in when he joins. So that's good. Thanks, Nancy.
Thanks.
Okay, so with that in mind, let's move on to the next speaker, and it's great. I mentioned a few people that helped out quite a bit on this one. Well, the next person is one that's really carried a lot of weight on this one. Is the IR4's state liaison representative from Hawaii. And she's been doing the lead for a lot of our work on coffee for many years. So Julie Coughlin, please go ahead and introduce the video.
Thank you, Jerry. Aloha, everyone. We're going to start off our tour with some Hawaiian music and a short video created by my colleague, Jerry Sugano. Jerry is our county administrator, and she recruited student volunteers to help us strip pick coffee berries in our research plots. Strip picking is a time-consuming task that is done as a sanitation practice to control coffee berry borers. Jerry made this video for the volunteers, and we wanted to share it with you.
Well, thanks, Julie, for the great video and all the work that went into putting that together. There's another individual that has played a key role in putting this together, and our friends and colleagues from Puerto Rico, Wilfredo Robles Vasquez. And Wilfredo will be talking in a few minutes, but wanted to give a chance for him to introduce the next speaker. So Wilfredo, over to you.
Yeah. Hi, everyone, and thanks for joining us on this virtual tour. Just want to introduce one of my colleagues, Professor Carlos Flores. He's an horticulturist at the Agricultural Experiment Station who has been working with coffee research for the past 25 years. His research interests are related to field assessments of coffee varieties resistant to coffee rust, while identifying the best culture practice to improve crop yields. Professor Flores is the former Secretary of Agriculture in Puerto Rico, which allowed him to work directly with coffee growers and provide government resources to support coffee industries. So with that, I'll let Carlos Flores to go ahead and start his presentation.
Thank you, Dr. Robles. I'm trying to get the camera, but somehow I can show my face in the video, but you can see the presentation. I guess that there is no problem with that, right? All right, I am.
Everything is good, Carlos.
Okay, well, I'm going to try to give you a real quick view about the domestic economic value of the coffee in Puerto Rico, which is going to be just a very quick review because of the time that we have. But actually, we need to speak before and after of Puerto Rico. Let me see if I can show it here. It says cannot start the video. All right, now. Puerto Rico and Hawaii are the only USA geographic areas that produce coffee. We all know that the territory and Hawaii governments are under the USA Constitution. We have similarities in terms of labor, agriculture, trade, and environmental regulations. Compared with other coffee producing countries, Puerto Rico and Hawaii have the highest production costs in the world. Next slide. Okay, just to give you an overview, I know that you are more expert in Hawaii than we do, but in Hawaii in 1828 was the first time that coffee was planted in Kona Island. And in 1930s, became a commercial crop in Hawaii. Based on the studies that we have, approximately 715 small coffee farmers still planting coffee. Is a robust industry based on quality, and also not only in Main Island and Kona, they do have coffee also in Maui and Molokai, Oahu, Kauai. I had the opportunity of visiting three times Hawaii, studying their coffee industry, but the famous of all is that they sell their coffee very good. These last crop, 2019-20, value was of approximately $102.9 million. That is something very, very exciting and very good. The next one. So in Puerto Rico, I'm going to try just to speak before and after Maria. Next one. Before and after Maria, Hurricane Maria that hit us in September 2017. But actually in Puerto Rico, the first coffee was planted in 1736 in the municipality of Coamo in the southern part of Puerto Rico by the Spanish colonizers at that time. In Puerto Rico, the production of coffee is primarily located in the central western part of the island. It covers about 22 municipalities. People in the mountain region where we have high elevations. Today, there are approximately 2,292 coffee farmers small coffee farmers to medium, average of 10 to 15 acres, 28,000 to 30,000 acres cultivated. We produce for the last year after the recuperation of the hurricane, 26,000 quintals. That was our total production last year. That's account for a gross value in the coffee industry of about $9 million. So we are trying to get back of our full production. This is the area that we mostly have the coffee area. It's very localized area based on temperatures and the condition of the soil. And the next one, I'm going to show you that today in Puerto Rico, the difference in Hawaii and Puerto Rico is that we are primarily producing coffee for our local consumption. Our local consumption is about 320,000 quintals. Out of that, 290,000 is imported today. The government imported coffee and sell to the roasters. And we are producing the 26 to 30,000 quintals, very, very low. And export, it's only 1,800 quintal. When I mean quintal, it's 100 weight for export. But things somehow are changing in Puerto Rico. Next one. We are also experimenting a transformation of the coffee mills, or what we call the beneficiados in the mountains. Sharing with the tourism, agritourism, and many other visitors, there had been an increase and multiply the coffee mills, dual purpose, also for producing coffee and also for agritourism. We have about 72 coffee roasters that they buy local coffee, but also imported coffee to produce approximately 90 different branches of coffees in the island. But one thing is that the new wave of younger farmers and the new technology has impulsed an increase in the coffee shops in Puerto Rico. Over 230 coffee shops has been established in the last 5-10 years, which is something very good. We didn't have that before. And this new wave is looking for not only the drink of the coffee. The next one, I'm going to show you some of the areas that the people are more interested today. Not only the coffee shop and the traditional coffee, but there's the different pantry, different mermelada, different candies, also the byproducts using for compost, for candles, for the smell and the aroma, soaps, and also kind of candies that has been also in using the coffee with this new generation. So that is also what we are positive expectative in the coffee industry. Thank you.
And now we'd like to welcome Suzanne Schreiner, a second-generation coffee farmer in Kona. She is also the administrator of the Synergistic Hawaii Ag Council, a stakeholder group working on behalf of coffee, papaya, floriculture, and macadamia nuts. Welcome, Suzanne.
Good morning, everyone from Hawaii. This is Suzanne. I don't see myself on the screen yet. There we go. Coffee has a long history, as the professor just mentioned, here in Hawaii. First recorded plantings were back in the early 1800s, as well as a flood of other plants that were brought in from the whalers and the missionaries who were looking to bring the crops they loved to Hawaii. So it quickly became an important crop economically, to the point where in 1842, the Kingdom of Hawaii taxed imported coffees to protect our Hawaii growers. And at that time, most of the ag in Hawaii was plantation style, and there were large plantations on Kauai and Oahu. In the 1860s, they were hit with a white scale infection brought on by ants. So the plantations could no longer economically grow the coffee. The labor costs were too high. So that commodity crop collapsed, and it became more the avenue of a smallhold farmer who would grow coffee. And it moved to the Big Island, and this became the ground point for the history of Big Island coffee. Hawaiian and Japanese growers who had previously worked in plantations and sugar crops transitioned to small farms here on the Big Island. And you can see through the slide, the coffee crop itself is well suited to Hawaii. Here on the Big Island, we have rocky soils. You can see in the upper right-hand picture, the seed just takes hold in that lava rock in a small hole and will grow right through the lava rock. It does very well. It's perfectly suited to our Hawaii conditions. Next slide. Moving to the current era, the commercial crop really took off in the early 1900s because our smallhold farmers, the crop stores very well. It's a seed crop. At the end of the day, we're drinking a roasted seed from the coffee plant. And so it could store well and ship well across our ocean distances. As of the last NASS census in 2019, I believe, we have 1,477 growers across our 5 islands. And these, as I said before, are largely smallhold growers. The average size is under 5 acres, about 4.7 acres. We have 5 or 6 larger farms. Our largest farm on Kauai has about 3,000 acres. So that skews the total acreage up. But here in Kona and Ka'u and Hamakua, our farm size has stayed small. And that was partly because it takes a family to manage 5 acres. To pick the harvest comes in from October, roughly August through November, with the peak in October. To hand harvest this coffee, it takes a family of 5 or 6 to get it off the trees. And today we use workers, but back in the early days, it was still family farms, family management. And to this day, it's still hand harvested, it's hand managed. We are not mechanized, with the exception of the larger farms, which do have some mechanical pickers. It's almost entirely unmechanized farms on steep, rocky slopes, with a large percentage of our growers being minority or socially disadvantaged because of the farm size or ethnicity. So having said that, we are still a specialty crop, and we have a lot of pride in our coffee. Most of you are probably familiar with Kona coffee. It is the brand that everyone knows and loves from Hawaii, but we also have excellent coffees in Ka'u, Hamakua. Maui coffee has a growing reputation with a number of small farmers over there. And we also have farms on Oahu, Kauai, and Molokai. So the Hawaii coffee brand is strong, it's family-based, and we're looking to protect that going forward. Thank you very much.
Julie, you're muted.
Thanks, Jen. Sorry. Next up is Chris Manfredi. Chris serves as 6th-term president of the statewide Hawaii Coffee Association and is past president of the Hawaii Farm Bureau. He is a Hawaiian coffee wholesaler. Chris is a strong advocate for Hawaii's coffee industry and is best known for his work in building the Ka'u coffee brand and community. Welcome, Chris.
Thank you, Julie. Good morning, everyone. Thank you for inviting us to participate in this coffee tour. It's very important for us to get our message out, particularly to this community as we battle the scourge of coffee leaf rust that's currently engulfed Kona is found on all coffee growing islands. And we've been working hard to adapt to life in coffee after CLR. We successfully were able to manage coffee berry borer when it was found here in 2010, and now we're dealing with this new threat. Coffee is the second highest valued crop in the state of Hawaii, behind seed corn. And as Suzanne mentioned, they're primarily smallholder farms, hand harvested, managed by a family unit. While at the same time, the largest farm in Hawaii is a coffee farm that's mechanized. So it really runs the gamut. But there's a lot of families, a lot of constituencies that depend on the coffee industry, both at a farm level and at a retail level, as well as some spillover into tourism and land preservation. Unroasted value is $102.9 million in raw form. Downstream economic impacts, 211 million. Upstream economic impacts are not fully quantified. There is a USDA economic impact study pending, which we hope to have the results of within the next 60 days. As I said, the vast majority of farms are family owned and operated. Next slide. So here's a graphic of what coffee leaf rust can do to a farm. In this instance, on the left, we have trees that are not resistant to coffee leaf rust. And on the other side, we have those that are. And it's really just a depiction of before and after. You know, on the right is what the farms in Kona looked like last season. Leaf rust was first found here at the end of last year, so we've been dealing with it only for a little over a year. And the trees on the left are not atypical to what you'll see in Kona today. Next slide. So in Ka'u, where I am, and Suzanne mentioned, we're an emerging origin. The growers here are primarily former sugar plantation workers that were generationally dependent on the sugar plantation. When the plantations collapsed, they were able to persevere and transition into successful businessmen and women producing some of the finest coffees anywhere. The plantations were the dominant force here, and there's strong anti-development pressures. So there's very few other opportunities outside of agriculture in this district. And for those that are not active in agriculture, we see huge unemployment. We see crime, we see drug addiction, domestic violence, really sad. And, you know, the threats facing agriculture, you know, puts a lot of these growers in peril. Many of them have a once in a lifetime opportunity to buy their farms and create some equity for their families for generations to come. And they're securing mortgages presently to acquire those farms. And then they have this, the scourge of coffee leaf rust breathing down their necks, threatening their futures once again. In many ways, we're hamstrung with the tools that are available to us to be able to fight this disease. As Carlos mentioned, Hawaii and Puerto Rico are at a competitive disadvantage with coffee producing regions across the world. Our cost of production here is higher than anywhere. Cost of land, cost of labor, cost of fuel, cost of transportation is higher than than any place else. And we're required to be able to produce some of the finest coffee anywhere in the specialty market to be able to command the prices that make farms sustainable. If we're not producing a world-class quality crop, we can't get the prices that we need to stay in business. And that puts us at a competitive disadvantage because we don't have many of the tools that are available in other parts of the world. Again, I thank you for your attention. I thank you for your support, as do all the growers here in Hawaii. Aloha and mahalo.
Okay. All right. Well, thank you. And we have a slight change of agenda. We skipped over before Ed Messina, so I want to just bring Ed back in and say just a few words of welcome. Ed, floor is yours.
Yeah, thanks, Jerry. Can you guys hear me and see me? Am I coming through?
It's all good, Ed.
Yep.
All right, great. Well, thanks. Appreciate the collaboration. And actually, it was good I got to see some of the presentations first because, this is our part of our virtual crop tour series, and really appreciate IR for putting these together. We previously talked about cranberries and hemp, but I know that coffee is really important to many of us. And I'm glad we got to see, sad that this is happening in Hawaii, but I'm glad we got to see some pictures because we worked with Hawaii Department of Agriculture to approve a Section 18 for coffee lead rust up to 8,000 acres this spring. So that was based on the close collaboration that we had with our registration division in Hawaii. And so we stand ready to assist and understand and appreciate the issues you guys are dealing with, but it's important for us to see it in real time and get a sense of what it actually looks like. So thank you for the presentations, and look forward to learning more. So thanks everyone for joining today. Sorry about the confusion on the team site calendar invite, but it looks like everyone made it over, and looking forward to a great session and some good questions and answers. So thanks, Jerry, for your collaboration, and thanks for inviting me to say a couple of, just say hello.
Thanks, Ed. Wilfredo, back to you.
Thank you, Jerry. I just want to introduce another colleague, Dr. Fernando Gallardo. He's a well-known entomologist at the Agricultural Experimental Station who has been working with coffee research for the past 40 years. His research interests are related to the use of biological control and chemical control to manage coffee pests and diseases. As a result, many peer-reviewed articles have been published, which have benefited the coffee industry locally and internationally. So with that, I will leave Dr. Gallardo with his presentation. Thanks.
Okay. Well, I can see myself, but are you hearing me?
Yes, we can hear you.
Yeah, okay. Well, good morning in Hawaii and good afternoon here in Puerto Rico. It's around 3:30 here. I'm here in the experiment station in the center of the island where coffee research have been done for the past 40 years or more. And I want to thank the organizers for the invitation to participate in this coffee tour. I will talk about the major insect pests in Puerto Rico and what we have done for the past years and what we can do. Next slide, please. Before I start talking about the coffee pests, we need to framework this situation in Puerto Rico. Well, as Hawaii, coffee is a primary crop for the center of the island. And many Puerto Rican are very identified with the coffee production. It's related with all our culture that came from the Canary Island and all Mallorca and Corsica, that these Europeans emigrate here to Puerto Rico to cultivate coffee. The local industry in Puerto Rico has been struggling for years with many issues that you have also in Hawaii, but the Hurricane Maria in 2017 was really very tough on the coffee production. Next slide, please. And we lost more than half of the farm in 2000 when Hurricane Maria devastated the local coffee farm. We lost more than 80 million coffee trees, and only a small part of their farm have survived up to date. Next slide. As in Hawaii, coffee farms in Puerto Rico are small and medium-sized producers, and this is very important because the practices that they're gonna establish on the coffee farm are related to that small size and economic people that are in disadvantage to other farmers in Puerto Rico. Next slide. We have two major pests, the coffee leaf miner and the coffee berry borer, another minor pest that can be found in some areas that not are the major coffee production areas. Next slide. Coffee is cultivated, as mentioned Professor Flores, for more than 200 years in Puerto Rico, and the coffee leaf miner was the major pest for 200 years before the coffee berry borer was found in 2007 in Puerto Rico. And from that time up to now, nobody talks about the coffee leaf miner. It's no, I don't know what happened, but that's a major concern about public, the impact of the news on farmers. In 2007, everybody was talking about coffee berry borer and have to be done something about this pest. And right now, it's not also mentioned any of these pests. Next slide. Coffee leaf miner was a pest that can defoliate coffee plants and decrease production by 50%. In some areas in the Caribbean, it's a limiting factor for coffee cultivation, especially in lower altitudes where more dry conditions prevail. Next slide. For more than 50 years, the coffee leaf miner was controlled by annual application or soil application of the disulfuton. And the Puerto Rico Department of Agriculture established a technological package for promoting the coffee production. And if a farmer wants to receive that technological package, that means dollars, I mean money, there was a mandatory to apply the soil insecticide every year. The application were performed by the Department of Agriculture brigades under the Crop Protection Division. But in 2009, this insecticide was banned from the market. And in 2017, the Department of Agriculture, the government closed the Crop Protection Division. So farmers have to be by themselves if they want to apply any pesticide on their farm. Next slide. In Puerto Rico, all these are the insecticide registered for using coffee. the imidacloprid is one of the ones that are using some farmers, not all, but they have these tools available to control this pest. Next slide. But there are some cultural practice that the farmer is recommended to do. One is the wind breaks to promote the presence of entomopathogenic fungi, because increase the humidity in the plantation. And also we implement a decrease in the planted distance, so we have a more close plantation, so that the infestation is secluded to the borders, and in that area is more directed for a control to be applied. Next. Also, we have biological control. We have a complex of more than 7 parasitoids, and we have the Ebraconi that was introduced in 1940 to Puerto Rico, that in some areas is supporting a lot of mortality to the coffee leaf miner larvae. Next slide. Also, after the presence of the coffee berry borer, you can see there that Bauberia bassiana is commonly found infecting the coffee berry borer. And also we observed that this increase in inoculum also is infecting the coffee leaf miner. Next slide, please. Here I show you how the moths and the pupae are infected with the Bauberia bassiana in the field. Next. So after that, the coffee bean borer has been a major pest and found in 2007 here in Puerto Rico. Is widely distributed, is everywhere. And it is estimated that 20 to 30% loss at farm level. And economically, that means the loss of 30 cents per pound of coffee beans that are sold at the farm level. Next slide. Cultural practice is the main control to decrease the infestation, and it's well done in these farms because small farms that are run by families, they depend on that on that harvest. So it's the control is very well done, and this is one of the major IPM control for this pest. Next. Also, when the natural infestation of B. bassiana is observed everywhere where high humidity is, and we recommend to apply the mycontrol when farmers can check and get the coffee berry borer in position B. We can observe that 50% infection at high areas where humid conditions prevail. Next. Also, we have a parasite, Cephalonomia stephanoderis, and also is naturally observed. I mean, we never liberate the parasites here. They came with the broca, and we got 23% infection before Hurricane Maria. Right now, this population has built up and depends on coffee berry that can be left in the tree for next generation. Here, in Puerto Rico, we have a lot of Robusta coffee in some areas that farmers are not harvesting. And in those trees, we found a lot of infestation with the parasite. Next. In the case of the coffee berry water, there are not many insecticides that can be chemical insecticide that can be used for the farmers, I mean. So this is an area that we need more investigation and more research to do to get more tools available for the farmer next. Also, Beauveria bassiana have been studied, have been well, a lot of work done, and we found that the local strains survived and persisted better in the field than the Micotrol and have the same virulence on the coffee berry water. This is a research done by a group of Dr. Bayman in Rio Piedra University. They published already this in biological control. Next slide. Also, we developed a handbook or guide for farmers to implement a control of the broca, where they establish decision making by knowing the percentage of the broca, but they had to do scouting, and depends on the position of the broca, they can apply chemical or apply the fungi, or do not or not apply, I mean. And that is based on the phenological cycle of the coffee. But in Puerto Rico, right now, the coffee berry water, any farmer are doing anything for controlling this pest. And this is an issue because the pest is there doing damage, but when they collect the coffee beans and go to sell it to the beneficiadores or the coffee mills, they buy the coffee. Don't worry about if they have broca or not. They give the same price. So farmers then don't consider that they're gonna put any effort on controlling this pest. I don't know how the coffee mill is managing this, but that's the reality right now. Next slide. So if you have any question, I'm sorry for my English. I need to practice more, and everybody here speaks Spanish. So thank you.
Thank you, Fernando.
Okay.
Next, we have John Ching, General Supervisor for Coffee and Cacao at Dole Food Company. John has over 13 years experience supervising field operations in coffee production in Hawaii. Welcome, John.
Thanks, Julie. Good morning, good afternoon, everyone. I have a background, orchard production and management in coffee in Hawaii. Previously, I've also worked at Kauai Coffee Company. So a brief overview about air blast spraying in coffee orchards. So air blast spraying is industry standard foliar applications, pesticides and fertilizers in larger coffee orchards. So there are different type of air blast spray systems. Conventional fan spraying systems, the top picture on your left is flow rate is adjusted by different nozzles, different spray tip sizes. Different other system is air shear through Venturi system, also electrostatic system. So airflow generates droplets and water is regulated by adjusting the different orifice sizes. So in Hawaii, majority of the coffee growers, they use this Gearmore Venturi system, and it's been proven to be pretty effective. So air blasting primarily is used for pest control, CBB, coffee green scale, as well as CLR. And correct me if I'm wrong, but to my knowledge, no farms have air blasted with Preaxor for CLR. Next slide, please. So for air blasting, it's proven there's no alternatives for air blasting. It's basically a tried and true method. It's best possible way to treat acres, providing best coverage. So one single air blaster can cover anywhere between 10 to 20 acres per day, depending on different factors, field terrain, travel speed, and different application rates. Whereas one backpack sprayer with a mist blower, he may be able to treat a couple acres a day, and that's going up and on a row, and each row would have to be treated, both sides. So definitely more labor intensive. Next slide, please. So over the years, air blast spraying has greatly improved. From the beginning of spraying, from using large volumes of water with hand spraying all the way through air blasting technology, and also with electrostatic spraying, which droplets are charged to basically adhere better to plant area. And in air blasting methods is a critical component in all different types of orchard and vineyard crops. So mechanization is the key in larger farms, and without air blasting, it would be extremely difficult, inefficient, and costly to control pests in larger coffee farms. Next slide. That's all I got. Thank you.
Thank you, John. Next up is Dr. Lisa Keith. She is a research plant pathologist at USDA Agricultural Research Service in Hilo, Hawaii, and her primary research interests include biology, detection, etiology, and control of bacterial and fungal pathogens. Dr. Keith uses a combination of lab, greenhouse, and field-based techniques to develop and deliver practical disease management strategies that can be adopted by growers. Dr. Keith has been leading the pathology efforts on coffee leaf rust since its discovery in Hawaii in late 2020, and was granted federal identification authority for identifying CLR records in Hawaii. Welcome, Lisa.
Thank you, Julie, and good morning and good afternoon, everyone. Just a friendly reminder, I guess, to start the talk, how disease is actually caused in plants. So you're looking at the disease triangle with the three critical components of having the pathogen present with susceptible hosts and a favorable environment. And the environment's actually quite a complicated portion of the triangle. And we have many, many microclimates in Hawaii. And all parts of the disease triangle actually have to occur at the right time and the right place in order to have disease. Next slide, please. And so what you've heard mentioned, the disease coffee leaf rust caused by the pathogen Haemoleia vistatrix was actually first detected on Maui in late October 2020. Soon after, in Hawaii Island on the Kona side, and really within 6 to 8 months, the pathogen and the disease had spread across the state to all of the islands growing coffee and the 5 commercially islands producing coffee. Next slide, please. So a brief background on its biology. Haemoleia vistatrix got its name off of the half-smooth spores and the devastating nature of the pathogen. These are very unique spore shapes. These are rhodineous spores that you're looking at under the microscope for coffee leaf rust. H. vistatrix is known as an obligate parasitic fungus, which means it needs a living host to survive. And actually, coffee is the only host necessary for this pathogen to complete its life cycle. And basically, once a spore lands on a leaf, it waits until conditions are right to germinate. Next slide, please. And this picture describes the overall disease cycle. As mentioned, the spore lands on the leaf, the spore will germinate into the stomates on the underside of the coffee leaves, essentially tap into the host system. I guess a Star Trek reference would be almost like the Borg. It taps in and grows intercellularly, starts sapping the energy from the host. The spores then and the mycelium germinate back outside of the stomates and start producing more spores. And it's pretty common knowledge through the literature, no matter where this disease occurs in the world, that wind, rain, and worker activity help disperse spores. Again, infection only occurs through the stomates on the underside of the leaf with the characteristic temperature ranges and optimums, which of course are pretty much most places in Hawaii. Once sporulation occurs, it takes about 2 weeks for infection. Those spots will actually increase in size over a few weeks, and it's quite devastating because a single spot can actually produce hundreds of thousands of spores over the next few months that can cause new disease. Now, survival for this pathogen, the spores can actually survive about 6 weeks on its own, but remember, it needs a living host to survive. So the fungus really survives primarily as mycelium within the living tissue. Next slide, please. The first thing really was understanding and proving pathogenicity. And so these are what the studies occurred in Hawaii to understand the symptoms, meaning how the host responds to the pathogen, and the signs, the actual physical presence of the pathogen itself. The first observable symptoms when we inoculated susceptible coffee varieties are these small pale yellow spots. That's the top picture you're looking at. On the upper leaf surface, now it starts to go chlorosis. And on the underside of the leaf, spores develop approximately 21 days post-inoculation. Okay, the spots gradually increase in size. You start to see those characteristic yellow, orange spores being produced on the lower surface. The spots increase, the centers become necrotic, and when enough inoculum is present, leaves start to fall off approximately 7 days after inoculation. Next slide, please. A lot of work is being done collectively. The first, I think, key things that we developed were visual aids and molecular methods for early detection for coffee leaf rust to be able to decipher from other pathogens causing disease in coffee here in Hawaii, and also good sanitation protocols. But we're trying to get a better understanding of the pathogen, its biology, its disease cycle in our environment. We're looking at management options, particularly longer term, which would be development of resistant varieties and testing of varieties, and also looking and understanding if there are natural enemies present. And then fungicides are actually another key component to management. Next slide, please. And we've been involved in fungicide testing predominantly in the laboratory and one field study at the moment. Next slide, please. With our in vitro fungicide assays, we collect fresh inoculum on leaves. We bring that back to the lab, actually collect spores off of the leaves, adjust the concentration, typically mix it with whatever fungicide or product we're interested in testing, plate it on water auger for the moisture, and then incubate the plates in the dark for approximately 12 to 16 hours. And then we'll look at the spores under the microscope and actually look for germination. That top picture on your left shows these large germ tubes that are formed. And we're hoping to find products that result in the picture on the bottom, actually all elimination of germination. So no germ tubes present. So actually stopping germination of these spores. And the types of products we've been looking at, we've done the testing for everything registered for use in Hawaii. We've partnered with Julie and the IR4 program to try to get a good first glimpse at what it will do to spores in the laboratory with the primarily systemics that she's going to test in the field, and pretty much other available, maybe Omni certified or other products that we can help get a first, again, to understand a bit more of what is going on and prioritize the types of products we will look at in the field. And really, we've noticed that direct contact and timing is key. Now, just to give a brief update on a field fungicide trial, we were aggressive in the management using the products available for use in Hawaii, which are all protectants, and using combinations of coppers, the biologicals like Serenade and double nickel and oxidate. We actually saw good control, but again, it was very aggressive spraying approximately every 2 to 3 weeks for these products according to label, and getting a better understanding of how this aggressive management can affect the incidence, how many spots there are per leaves, the severity, the actual area of symptoms on an individual leaf, and how it affects germination of spores. Next slide, please. So some of what we found so far, as this new epidemic has occurred in Hawaii, that lesions can occur and actually develop anywhere on the leaf. The first spots usually appear typically as the disease progresses season after season. The new symptoms will develop on the lower portion of the tree because infected leaves fall to the ground and then they're splashed upwards and the start of new infections. But for us, again, the initial stages of epidemic, wind-blown spores, the first spots can actually occur anywhere in the canopy. Now we know that multiple infections occur on the same leaf, seeing different sizes of the spots developing. What happens, our leaves are dropping prematurely. We saw some pictures previously. That's a picture on the right. You see these twigs with no leaves. Right now, we are seeing regrowth. And the survival of the inoculum going forward will actually depend on the overall disease severity and the extent of defoliation. Next slide, please. So to give a little, I guess, a better glimpse at what's going on in Kona with coffee leaf rust incidence and severity, Dr. Melissa Johnson of ARS in Hilo has been doing monitoring pretty much from the start of the detection of coffee leaf rust. And you can see what the graph is showing as far as incidence average, probably from about 20 to 25 farms in the Kona region, is that incidence remained rather low until harvest season started. So somewhere between August and September, there was a marked increase in incidence, which unfortunately does make sense because going through pickers, harvesting, a lot more movement of spores, and you see the incidence increase. And these are just some examples of a timeline of pictures on the upper right, showing a process of every 3 months starting in February, pretty much clean leaves through May, starting into harvest, definitely incidence and even then severity in some cases have increased. Overall, lower elevation farms right now, particularly in Kona, have lower incidence on average. But we also have to remember that this increase in incidence isn't necessarily reflecting the increase in severity yet. But again, we're right in the beginning of this epidemic. And unfortunately, we do see examples like the bottom right. These are the same trees in the same location, 2018, so prior to coffee leaf rust, and what it actually, this tree looked like with a heavy fruit load and this defoliation. So that's kind of a worst case scenario we're looking at. Okay, next slide, please. Really, so what we learned so far, How to combat coffee leaf rust in Hawaii? Well, we know that this impact can be long-term, and the disease has to be managed as a continuous epidemic. The overall goal really is to reduce sporulation, the spore dispersal, and or the infection rate of the pathogen. And of course, there is no silver bullet. We definitely have to use an integrated pest management approach, which is going to incorporate short and long-term strategies, definite scouting for early and accurate detection of the disease. Maintaining plant and soil health is very, very critical. Practicing good hygiene and sanitation. Now, resistant varieties, biocontrol, more long-term strategies, and really the immediate need is an important tool in this whole IPM are fungicides. And currently, really, we have mainly protectants. And as I expressed that, it's the mycelium within the leaves that is going to have to be knocked out to really start to control the disease, which is why systemic fungicides are so key. And next slide. And I appreciate the teamwork that goes on. The people in my lab are cooperators and collaborators, and I say thank you very much.
Thank you, Dr. Keith. And I know we're going a little long here today, but I think we still have one more presentation, and it's my pleasure to introduce an old friend, an old colleague who many of you knew from many years working for IR4, but Dan Kunkel is no longer with IR4. He's now in the private sector, but I'd like to introduce Dan to make a few comments about the Minor Use Foundation and some of the work they're doing to help with some of these export MRL issues. So Dan, it's yours.
Thanks, Jerry. Can everybody hear me all right?
Yes.
Yes, okay, great. I can't see myself, but I won't worry about that. But thanks for the invitation. We wanted to just say a little bit about what the foundation is, some of our activities, and some of our ongoing projects. So it's great to be a part of the tour and see everyone again. So I guess, I can advance this slide, great. So the foundation, a lot of familiar faces here. Dirk Dross is our chairman. He worked for Syngenta previously, and then he's retired. Ellen Norden, former APVMA executive director. Michael Braverman, you all know him with the biopesticide program and international activities. Jason Sandall from USDA Foreign Ag Service. Myself as executive treasurer, and Jerry's our ex officio member. And I believe the program started, Jerry, it was 2016, I think, is when we started to form the foundation. And part of the reason behind that was because to take a little bit of the burden off of IR4, because IR4 had been carrying the torch for so long on the international activities. But the organization, we try to establish collaborative international approaches to maximum residue limits. These are standards that are used in trade for specialty crop growers and minor uses. We implement priorities. We have a global priority setting summits, usually about every 3 to 5 years. There's also a number of regional priority setting workshops as well that set priorities. And then we try to raise funds so we can provide funding for these research programs to help obtain new uses for growers, and then also provide MRL standards and harmonize those standards around the world. So we provide support, also training, train some of the researchers in some of the areas to do GLP research and generate this residue data. And we coordinate those activities with other organizations throughout the world. So we do continue to seek and obtain funding from other government grants foundations, other nonprofits. And we do have a significant amount of funding at this time. We are a 501c3 nonprofit. We're incorporated in New Jersey, also North Carolina, Oregon as well. Okay. So we do, we have the Minor Use Foundation, but we do try to provide coordination and guidance and funding in working with other government agencies, universities. Obviously, we spend a lot of time working with IR4. Another important member of this cooperation is the pesticide companies to provide products, ultimately register the products. And then we also work with grower associations to help us set our priorities. So just, we have various regions that we're working in, but these are just some of the projects we have in Latin America. Maybe Michael Braverman will want to mention some of the ASEAN projects that we have ongoing. But you can see here some of them in banana, pineapple, tropical fruits. I'm going to talk about some of the other priorities in an upcoming slide. If I can get this to advance. Oops.
I'm advancing it, Dan. You can just tell me. I am. You can just tell me when you want the next slide.
Pretty good, because I thought I was doing it. So this is our website, and I just wanted to put this on here because it provides a kind of a real-time progress report on our activities. You can see the blue dots on the map. If you click on those, as I did with the papaya trifloxystrobin a flupiram study in Costa Rica, you get real-time information about the ongoing project. So I invite you all to go and visit that and see where we are with some of our ongoing projects. Next slide, please. All right, so this is the trifloxystrobin flupiram study. We have Costa Rica and other countries you can see listed there. This is information from the IR4 database, so we're dovetailing with the IR4 database to add some of our projects and track them there. But let's talk about coffee. So next slide. So we have our top 10 priorities that we received at our workshops, and I know there's 15 priorities here. Some of them we can fund, some of them we can't. Some of them also you can see are also biological products, so we don't really have to get into doing residue studies for all the projects. But I've just checked off the funded projects, and on the next slide, before you do that, you can just see the coffee project. I just wanted to mention the pest there. It's coffee berry borer. So the next slide indicates some of our recent priorities that the foundation has agreed to fund. So in August, we picked up a passion fruit and okra project. And then in May, earlier this year, is when we picked up the indoxacarb on coffee project. And again, we talk about coffee berry borer. The next slide, please. And here's just some of the target, obviously, is the coffee berry borer. And you can see the assignments that we have. We have Uganda with 2 trials, Costa Rica with 3 trials. But I should mention, you know, if we're going to do an international project, we're going to submit it to JMPR. We really need a minimum of 8 trials. And probably with the European Union, we probably want to target 12. So the next slide. Yes, okay, great. So, you know, the one thing with the foundation is we want to make the biggest bang for our buck and use our resources as appropriately, but it's a two-way street. So we're dovetailing our project with IR4 as well. So we can use the IR4 data as well as the international data and then submit that to the JMPR for an international MRL. Okay, next slide. And I think that's it. I just wanted to acknowledge some of the support we received from the Standard Trade Development Facility, IR4, the Food and Agriculture UN organization. The Foreign Ag Service has been very supportive, not only in providing funding, but also in the creation of the Minor Use Foundation. And I think that's it. If there's any questions, I'll be happy to take them. Or if you want to send emails, as I mentioned earlier, Dirk Drost is the chairman. You can send him an email if you have questions. Thank you.
Well, thank you, Dan. And this concludes the formal part of the presentations. I believe we have some few minutes for questions for all the speakers. We have received some questions in the chat box. Some of them have been answered. But maybe before we close out, let's offer some verbal questions, and we can try to answer the questions that are in the chat box at a later time. Any questions?
So it does appear that I believe all of the questions in the chat have been answered. Kelly, I just saw your question. Will we send out the slides? We will send out the recording of this. And if the presenters approve, I can send out the slides as well. But definitely at a minimum, the recording will be going out within the next day or so. And I think all of the other questions were answered.
Thank you.
You're welcome.
Okay. Well, if there's no more questions, then I want to first thank the presenters for their excellent presentations. We hope that you all learned a little bit more about coffee, a little bit more about the challenges that we face enjoying our favorite beverage, or many of us our favorite beverage. So it's not easy, but we really thank the people that are out there trying to make the coffee that we so enjoy. And again, I want to thank the organizers and the staff that put this together. You know, this doesn't just happen overnight. There's a lot of hard work goes into it. So again, Van and Jen and Julie and Wilfredo, thank you so very much, and many others that are behind the scenes. So if there's not anything more, I think we'll end this particular virtual tour, and we're thinking about what's next. So stay tuned, and we'll talk to everyone soon. And best wishes for a wonderful holiday season, and we'll be speaking to you all next year. Bye now.
Thank you very much. Bye-bye.